Okay, so it seems like everyone is launching their own agentic framework here. We've heard for the past couple of months that 2025 is the year of agents, and certainly everyone's jumping in with their own take on how to make agents. And in this video, I want to talk about smolagents, which is a simple library to build agents from Hugging Face that just got released last week. So to be fair, this is not Hugging Face's first attempt at making an agentic library. Originally, they had the Transformers agents, and I'm showing you here version 2, which was May last year. But actually, version 1, I think, was May in 2023. So that's been around. It really didn't take off, I think, for a number of different reasons. And Hugging Face seems to have come back and rethought this. And to be fair, they've rethought this in the light of a lot of other frameworks coming out and people now seeing what works, what doesn't work, where things get really complicated, where things are just too simple. All these sorts of things people have been trying to work out over the past 18 months plus for building agents. So smolagents from Hugging Face is certainly an interesting library. It's got a number of key things that sort of set it apart that I'm going to go through here. And then we'll have a look in Colab at some simple examples of code of how you can get started to try this out, etc. So one of the big advantages that Hugging Face has, which they're now sort of really taking advantage of here, is that they've got all these open source models on their Hugging Face hub. And this framework allows you to use any of those models. So they've actually got it set up so that you can basically call the models on the hub. Now, you will be limited a little bit to what models you can access, depending on whether you're a pro user, like as in a paid user or not, of Hugging Face. But certainly out of the box, it seems that they're using the Qwen 2.5 CODA 32 billion models. So that's definitely a good model that you can use to get started with this. Although I imagine a lot of people are going to want to be able to use things like DeepSeek Coder and stuff like that. Now you can use proprietary models in here. I will talk about that as well. If you want to use OpenAI, if you want to use Anthropic's Claude, etc., all those things are possible in here. So let's jump in and have a look. So first off, they start off talking about what agents are. And I feel like this is getting to be quite repetitive, but certainly we're now starting to have people converge on definitions of what these are. So they talk about the whole idea of agency, of the sort of ability to take action in here. And I would say that this is one of the sort of key things that we've been seeing different frameworks approach this idea of agency in different ways. So if we go right back to things like Baby AGI and AutoGPT, etc., the challenge with those was that they had too much agency in that they decided everything themselves. They often didn't have tools at the start. Even when they did have tools, they were just randomly almost going out there and taking actions. And this just meant a huge bill for the amount of tokens, etc. Then on the other hand, we have frameworks like LangGraph, which really try to restrict the agency of an agent so that it can only do things that are on Rails. And that in 2024 showed to be the much safer way to build agents, the much more reliable way to build agents. We're now moving into the next phase as the models have gotten a lot better over the last year, where people are now starting to think, okay, maybe we can give some of the agency back to these agents that we're building in here. So they've got this nice sort of description here of the agency level, of what these sort of mean, and then how that's called, right? Whether that's basically you're giving them tool calls, so tools, whether you've got multi-step agents, where they're going in a loop, where you've got multiple agents going on here. And you can imagine with things like multiple agents, we've seen that being done with things like Crew AI, with Phi AI, with a bunch of other things that are out there as well. And I think the big debate at the moment around agents is really, do you really even need any sort of sophisticated framework? You can basically just use something that's very light, like Pydantic AI, to do your calls. You can write all your tools and functions and stuff like that in pure Python. And it does seem that the idea here is that smolagents is trying to place itself in the middle of this, of where you can go both ways for this. Now, they do have a graphic here of an agent running in a loop where it's executing different tools or different things at each step. And this is on the upper level of how much agency do you want to give an agent going through here. And you can see that a lot of the patterns that they use in here are very similar to things like the React pattern, which I think I made a video for almost 2 years ago. So a lot of those sorts of things haven't changed. They have a whole section in their blog post about when to use agents, when to avoid agents. I certainly would concur with most of what they've got in here, that for a lot of things, people do not need agents. People are making a big deal about things that can just be done as a simple workflow. If you haven't seen the recent Anthropic blog post all about that, I'd recommend you go and read that. I've put a video all about that with some code examples and stuff on my Patreon for people who are more interested in that. But really, the only times you want to use agents are when you've got some kind of dynamic decision making that's happening in this flow, and the flow can change directions, right? It can go off in different angles and stuff like that. So the big thing that sets small agents apart from other frameworks that are out there is this whole idea of code agents, is that they're really going back to the idea of getting the agents to communicate to itself in code and work things out in code. Now, they mentioned some research papers to justify this. Well, one of the ones that I didn't see that they've included there is actually the PAL program-aided language model. And this goes back to 2022. The latest version of the paper, I think, is early 2023, but originally this came out in 2022. I did a video about this. Again, we're coming up on close to 2 years ago, of the idea of getting the LLM to write code and then use that to help it. Now, that has been advanced a lot in papers like this Code Act paper, right? The Executable Code Actions paper. And what that paper really showed us was that often it's going to be better to get the model to use something like Python to execute code and adjust any feedback with that. So this doesn't totally eliminate text and JSON, etc. You can still put those things in there, but it also allows you then to be able to pass back other objects. It also allows you to take advantage of a lot of these models that are being trained for coding use now. So I think this is a really interesting direction that Hugging Face have gone here, and that the small agents team have gone here, is looking at incorporating. So they've actually got sort of code agents and tool calling agents in here. Okay, some other things just quickly. They really emphasize this idea of first-class support for these code agents, that these are thinking in or writing their actions in code. And one of the good things with that is that can be run in a sandboxed environment. So it looks like out of the gate, they're already supporting E2B, which is a nice way for running sandbox code for LLM apps and agents, etc. But they do also mention in here that on top of the code agents, they still are supporting the tool calling agent. So you can use that if you want to do something. Finally, I mentioned earlier that about the transformer agents. They do refer to this as being the successor to transformer agents, and that transformer agents will be deprecated going forward. So if we have a look at how they build these agents, one of the cool things is you don't require a large amount of code to get going. So you can see from small agents, we're importing the code agent, the DuckDuckGo search tool, and we're importing this Hugging Face API model. So really what that is just going to be able to use Hugging Face models by calling their API in there. And you can see we just instantiate that as a model in here, pass in the tool, and then we can pass something in and we will get our response back. It will decide whether it needs to do multiple steps in there. It will decide what tool to call based on what tools you put in there, etc., as you go through. So to get this going, really, you basically just need to pass in a model and some tools. And like I mentioned earlier on, if you don't want to use one of the Hugging Face models, you can always use Light LLM to be able to use things like OpenAI, like Claude's Anthropic, etc. Now, they have an example in the blog post of basically making a custom tool for this using the Google Maps API. And this looks just like basically a normal tool that you would define in most of the agent frameworks out there now, in that you would use the doc string to basically tell it that you're using args, etc. In this case, you've got your imports in there. It's going to run through using this API and then return back, in this case, just the text from that API call. And we can see that to use this, we've got a code agent where we're just passing in this custom tool, passing in the model that we want to use. And one of the cool things is that we can also pass in this idea of additional authorized imports. So just like we would want to restrict what Python packages get used in our sandbox, we can actually tell it that, okay, apart from just using standard Python, you can also use datetime in this. And you'll see in some examples in the Colab that you can pick to use things like pandas, beautiful soup, if you want to have it automatically do some scraping and stuff like that. So you can make use of that sandboxed Python environment to have the code agent run various things that are in there. All right, let's jump into the code and have a play with the code and see how it works actually in Colab. All right, so if we come into the code, you'll see that this is pretty easy to set up. So they've got a Python package for smolagents. If you want to use proprietary models or external models that are not in the Hugging Face ecosystem, you can use LLM in there. Because I'm going to be showing using the GPT-4o OpenAI model, I'm bringing in a key for that as well. You will need a Hugging Face token key, or you will need to manually log in. That's because you're going to be using their API for the actual LLM calls. So you'll see that when we start out like this, one of the big things we're doing is bringing in this HF API model. So this basically just means that we're going to be using a model from the Hugging Face hub. Now, remember, these are not necessarily models that are made by Hugging Face. In fact, the model that we're going to be using by default is going to be the Qwen 2.5 Coda 32 billion instruct model in here. But if you want to set the model, you would basically pass that in here as an argument. Now, to do that, that's why you need the Hugging Face token coming in here. All right, so to get up a simple agent, unbelievably simple, right? We just literally do from smolagents, we're importing the code agent, we're importing a tool, in this case, DuckDuckGo search tool, and we're bringing in the Hugging Face API for the model. So you basically just need some tools and a model to get this going. You can see that we're instantiating the code agent in here, which I talked about before as being different than the sort of traditional kind of JSON agents. But you'll see that once we've got this set up like this, we can just do a run, right? So I can do agent.run. What is the cube root of 27? And you'll see that sure enough, it basically passes this into the Qwen 2.5, 32 billion. We get something back, which it's going to execute code, and we get our final answer out. In this case, it's 3, right? And it's basically come to that answer via running code in here. And it didn't use the DuckDuckGo search tool in there. It just used Python as a tool, and that's pre-baked into it. I'll talk about more about different libraries in Python and stuff like that as we go through. The next question I've given it is how long does it take to drive from Melbourne to Sydney? So you can see here that again, now it basically uses the same model because we're using just the exact same agent. It's now decided that the variables that it needs is travel time info. So it's going to do a web search and the query is driving time Melbourne to Sydney. Then it says, okay, let's print out what we get back. So we can see that, okay, it's obviously done a search, got a bunch of different links back. They've got a variety of different things in here for the distance. You can see here it's saying around 8 hours and 45 minutes for 880K. There's a few that are a little bit different and stuff like that. But again, it uses that data now to come out with a final answer of 8 to 9.5 hours in here. We can see the number of input tokens. We can see the number of output tokens for each step. And you can see this is like step 0. This is step 1 in here. We'll look at later on at the logs and you can sort of log things out, but just showing you that, okay, these are the steps that it took in there. All right. So now I thought I'd give it something much harder. And I asked it, okay, what year should have I bought Bitcoin to invest $1,000 and now have $1 million? So again, it works out pretty quickly that it needs historical Bitcoin prices. It does a bunch of searches for that, and it starts looking for data. in here. And it doesn't do a great job. And this is where you'll see where it fails. It writes a bunch of code. In this case, it's failed. Now, why is it failed? If we look at this, we can see that the code execution failed at line import requests because I haven't allowed that as one of the Python libraries that could run in this. So later on, we'll look at how to do this, but you can see that, okay, because of the following error, import request is not allowed. Authorized inputs are queue, random, date, time, stat, and math, iterables, etc. Right? We've got very limited number of Python libraries to be able to do this kind of thing. All right, we can see though that it's worked out some places that it could probably get the data. It's trying different ways to use the data. Even JSON wasn't allowed. So in that case, it didn't work out. So it then just you'll see that each time though, when it fails, it's basically trying out a different way to do it. In the end, it's sort of like, okay, let's just get some web queries and print these out and try and use those. Again, we've still got failures. And eventually it just reaches the max iteration. So it comes up with this table after 5 steps in here. And this is good that we can set this. And it's showing us in here, I think, basically the prices over time. Unfortunately, it doesn't work out that probably 2012, somewhere around $100 would have been the right amount for that. Anyway, finally, in step 6, it's coming back. You can see we used like 40,000 input tokens though, and 5,000. It does use a lot of tokens going through this, right? That's something that you will definitely notice in here. All right, how could we improve this? Trying to improve this is a few things that we could do. We could change the model. So here I thought, okay, let me try the Llama 3.3 70 billion instruct. Unfortunately, this model needs a pro subscription on Hugging Face. So maybe this is one of the ways that Hugging Face finally gets people to pay for their services a bit more, is that if they're giving away a lot of tokens on some of these bigger models, notice we can use this model for free, but this one we can't in there. And then in here, I started to add in some different libraries. So I added in requests, I added in BS4. I probably should have added in JSON in hindsight as well. And now I've asked the question, it's gone off. Again, it's failed at different times. This time more, it hasn't failed because of the input requests or the beautiful soup stuff. It's just failed for other sort of generic things in here as it's tried to put together this table. So given a lot more steps, it may have actually gotten there, right? Like it does look like it's trying to import a lot of these sort of common libraries that are probably not that dangerous to do this task, but it hasn't really managed to work this out. And each time it ends up hitting against this max iterations in there. So perhaps the answer here would have been giving it access to more Python libraries and giving it more iterations to try over time. Okay, next up is proprietary models. If you want to use a proprietary model, you can just use the light LLM model and then pass in the model IDs. In this case, I'm passing in GPT-4o as the model. I'm also passing in DuckDuckGo search, and I've just got the additional authorized imports as just math. So I think actually math is perhaps one of the standard ones in there. Really, perhaps you should have a sort of set of these that you're quite happy with, things like JSON, like pandas, perhaps some string libraries, etc., regex, etc. in there. Okay, so I've asked it to calculate the same thing for Melbourne to Sydney. It's gone off. This time it seems like it's wanted to use code more for doing this. I am still using the code agent in here, and we get some errors of where it's basically getting multiple errors in here as trying to fix up the errors as it goes through. I do find this frustrating for some of them. It'd be interesting to see if you give it like the O1 model, does it get a lot less errors than this? This also could be that the system prompt, which I'll talk about how to change later on, is probably written more for that Quen model specifically in here. Anyway, after running into these errors, it finally just does the sort of standard search and basically gets the results back as a string. And sure enough that it's able to use those, pass through these, and we can see the driving time for Melbourne is approximately 8 hours and 45 minutes to 9 hours. So GPT-4o probably passing a very similar sort of data, comes up with just an ever so slightly different thing. I wanted to try it also then with things like, okay, what is the current price of a currency conversion here? So this is basically converting from Aussie dollars to Singapore dollars. Please provide sources in your answer. This is something that I wanted to see also. Can it actually provide sort of the sources of where it got it from? And again, it runs into a lot of these things where it will error trying to run code in a way that it thinks it should be, right? But it does fix up from that and then goes back to the string example out. It is a bit frustrating that it gets a lot of these errors. It would be very nice if we could save these errors off and that your agent could use this in the future. And they do have a thing where you can add things to memory. So that's something that I'm certainly going to look at for the future. You could get something really nice like Voyager, where it's trying out these different things and it works out that these don't work, but then it remembers for the future not to do it that way for the next call going through. Okay, finally, it does go through and finds information out for that. It then basically puts that into code. And you can see it's done quite a nice job of getting these sources as a list of little dictionaries for the sources where we can see what the prices were. And if we click through on the URLs, they are actually working URLs. And so it's able to basically get that out and then give you all of that information out. So you can see here, I've just basically copied it and pasted it into a text thing. We can see if we come to the Bloomberg one, it's slightly different. I ran this earlier on, but it's pretty good that it's been able to give me the source and the actual correct information there. So that one I think is quite a nice win. And the idea here is that just as we did this for GPT-4o here, we could use any of the OpenAI models, we could use Anthropic models. There's a whole bunch of models that the Lite LLM package will support. So it makes it very easy to basically use those models in here. All right, so next up, you've got sort of tool calling agents. So this is more sort of reverting back to the traditional sort of weather ones. Here, I'm still using GPT-4o. They've got a dummy function here for get weather. It's going to return back, the weather is ungodly and torrential rains -10 in Paris. I don't think it's anywhere near that bad at the moment. We can see that, okay, it goes through and it just operates on this just as if it was a normal sort of React agent, etc., where it's basically getting the observations out and returning those through. All right, changing the system prompt. If you want to change the system prompt, let's say I set something up like this. If I want to see the system prompt, I can just do agent.systemPrompt template. In here, you can see the entire system prompt. It is very long. So it is interesting to look at how they actually set up each of these things and how it's got some rules at the end for doing this. You certainly could customize these for any sort of variations that you want on how to get the answer out, etc. in here. And we can see, looking at the end of their system prompt, you're going to owe some people a lot of money if you have to pay $1 million for every right task that the LLM does in here. All right, just looking quickly, I didn't have a simple way to count the tokens, but you can see, count the characters, like there's 8,000 characters in there. That's a pretty good size system prompt in there. So to override the system prompt, you can basically just set that in. And when you're instantiating the agent, you can just tell it that, okay, this is the Python interpreter that I want to use. This is the system prompt that I want to use. So if you wanted to use an external Python sandbox, etc., I'm pretty sure this is where you would drop that in here. And then you would update the system prompt for that. All right, just quickly looking at the logs out. If you want to see the imports at any point, you can basically just come down and do agent.authorized imports to see what's going on in there. And then if we do something like this, what are the latest articles on TechCrunch? You'll see, okay, it runs off and does stuff. If we want to actually see the logs later on of what happened in here, we can come in here and see this. And this includes everything from like our system prompt in there to the various things that's still all the system prompt for quite a long while in there, down to the actual articles out and links that it gave us back in here. It didn't do a great job at this task, by the way. You can also index in and see the agent toolbox. And if you want to, you can actually sort of write in a summary or inner memory from these logs. So this seems to be something that you can see that we're using where we've got the role user, role assistant, etc., going through this. And you can actually pass in a thing where summary equals true and it will summarize this, or it can actually have the full sort of memory of what went on in there. All right, lastly, just quickly for this, an example of custom tools. One of the things that you'll probably want to use reasonably quickly is custom tools. And this is pretty simple here. What we're going to do is basically we will inherit from this smolagents tool class. And that basically means that it requires a name, a description, very similar things to what we've seen for other. It's very interesting also that you're basically defining the input and the output of the tool. I like this idea a lot so that you can work out, okay, do I want the tool to return something back in a certain way that the model will then parse it to get out different information, etc. And you can see that we've got this sort of forward pass here. So we've got this thing where basically we import the different libraries for this tool. It can then basically go through. This tool is in their example, we'll just go to Hugging Face and look for the most popular model, I think, or the model with the highest number of downloads for a particular type of use case. So you can see here when I ask it, what is the most downloaded model for text classification? It goes off and comes back that, okay, DistillBert is the model that's the most downloaded for classification in there. And we can see that it's very easy to use once you actually define this model. You can use it in your agents and stuff like that. Another thing that was very interesting is it looks like you can also push your tools to the Hugging Face Hub. They're probably going to benefit from the fact that a lot of people will just upload tools as they make them, and then people will be able to use tools from the hub and import those as you go along. So I think that's going to be an interesting area to see, okay, what do people make? And as people push those to Hugging Face, how do they actually work, etc. All right, I'll leave it there for this video. Certainly one of the things I didn't cover, which maybe we could do another video about if people are interested, is the whole sort of multi-agent element of this, is that you can do a sort of similar to maybe like a crew AI thing where you have a manager agent that manages other agents and delegates to other agents in there. So I think that's probably worth doing its own video about, and perhaps something around agentic RAG with that as well in here. I'd love to hear from you any other ideas that you think would make some good examples for agents. I'm certainly going to play with this more. I do think it shows a lot of promise. I'm curious to see how much support does it get going forward. It would be nice to have some support beyond just light LLM for things. I'm not sure exactly how well light LLM supports things like the Anthropic models on Bedrock and on GCP, but that's something that I'm going to definitely check out now with this and try it and see how it actually goes. My only concern at the moment is that it tends to make a lot of mistakes at the start of doing certain tasks when using the coding agent. And I wonder how well those are being stored to actually learn from those for new agent runs. So that's one of the things. So whether you get around that by making custom tools to do exactly what it is that you want, but it's certainly going to be interesting to see where this goes. It really does open up the whole agentic thing to having more agency than a lot of the sort of traditional things like LangGraph, etc., but maybe still having some more control over it as opposed to things like Crew AI. Anyway, I'd love to hear in the comments what you think about it. If people have got questions or anything, please post them there. I will probably end up doing a few sort of follow-up videos for this. So if you've got any ideas for those, please post them below. And I may do some head-to-head comparisons to show some of those things off. Anyway, as always, if you found the video useful, please click like and subscribe. And I will talk to you in the next video. Bye for now.